Welcome to the third part of the webinar on the EICASLAB demo real-time embedded for BeagleBone Blackboard. We will focus on the second control design phase, the rapid control prototyping, and especially on its RCP On Field submode. The rapid control prototyping allows to validate the same control code, that is the application software, already tested in modeling and like real-time operative mode, working directly with the real plant. It includes two submodes, RCP On Field and slow motion. The RCP On Field submode allows to perform experimental trials by piloting the real plant with the EICASLAB RCP platform that executes in real time the overall real-time software automatically generated by the ACG for RCP, meaning Automatic Code Generation for Rapid Control Prototyping, advanced feature. The overall real-time software is the code composed by the application software, that is the control algorithm, which is target independent, and the basic software, which is based on a real-time scheduler and multi-threading programming techniques and is target dependent and able to manage the hardware interfaces. Specifically for this demo, the RCP On Field is actually executed, as already said, without a real plant, because the plant is simulated by using a separate project as real-time emulator. Note that the plant model will be always the same model used in modeling and like real-time simulation. In such a project, the plant project, there is of course the rotating table block, the disturbance mission that provides the disturbance torque, and the trajectory generator mission, together with interface blocks which represent the physical interfaces, with which this project will communicate with the project containing the control. In RCP On Field, the project containing the control pilots the plant. So, in the system layout of the project, all the blocks except the processor are disabled. The processor block contains the control function and the interface blocks for communicating with the plant emulator. So, the actors of the RCP On Field are the EICASLAB RCP platform that runs the control and the rotating table emulator that simulates the plant and communicates with the project containing the control, while the hardware target in this phase is not used. The plant emulator project and the project containing the control run in two EICASLAB instances and communicate through physical interfaces. In this case, Ethernet interfaces have been adopted. The overall RCP process on field is controlled by means of the RCP Manager tool, which is equipped with a friendly graphical user interface named RCP Manager GUI, which is subdivided in a menu toolbar, a RCP control panel, and 6 plotting areas for visualizing during the real-time execution the trends of relevant variables. It's possible to change during the real-time execution some predefined parameters, and at the end of the trial you can open a HTML timing report. So, during the trial execution, the EICAS control block computes the command which is sent to the plant emulator, from which the position measures and the desired trajectory are sent to the control. During the trial execution, you can automatically record on the EICASLAB RCP platform disk all the plant input-output and the host commands data sent to the controller, allowing then to run the slow motion submode. Let's work again on the software. We left the project in modeling and like real-time simulation operative mode, but now we will work in rapid control prototyping. So press the operative mode selection button and select the rapid control prototyping operative mode. By default, the RCP On Field submode is selected. The Sim Builder tool will load the system layout of the RCP On Field configuration. Note that changing the control design phase, we don't change project because you have the possibility to organize your project in more layouts, each one dedicated to manage a specific control design phase. And all the layouts are fully customizable in terms of hardware and software interfaces, while they share the very same application software related to the control. In the system layout, as already explained, all blocks except the processor are disabled. Let's open the processor block. The control function works on the measures coming from the plant, and all the activities of the processor work when the plant sends a measure. So they are not periodically scheduled, but they are asynchronous. More precisely, the processor input interface receiving the measure is asynchronously activated, as you can see opening the activation policy window of the block. It is activated by an external signal. And when the signal comes, the input interface works, and also after it, all the other blocks of the processor. Let's open again the activity scheduling window. In this case, we have to consider real-time scheduling. Consequently, besides the scheduling parameters previously described, you can group your activities in threads and assign them to the cores of the EICASLAB RCP platform. Since only the processor blocks are active, all the other activities are off, and the blocks of the processor are put on the same thread because they work together. First, the interface that receives the measures and the interface that receives the desired trajectory, then the control function, and finally the output interface, as it is described by their relative phase. The scheduling parameters are expressed in terms of the current tick. And you can notice that the control has a worst-case duration of 5. If, during the trial execution, the control duration exceeds this duration, a warning will be given. In RCP On Field, the internal layout of the processor block has physical interfaces for the real networking. Double-clicking on an interface, you can see their parameters. We work here with Ethernet parameters and UDP protocol. You can configure a set of hardware interfaces available on the PC, such as USB, RS-232, or data acquisition devices by National Instruments. If you need to develop a specific hardware interface, you can program it on your own by means of the user interface. You can also select a virtual interface, which is no more a physical interface, for managing data exchange with a block belonging to the same hardware target. It can be useful, for example, because in some control design phases, two blocks may be on the same hardware target, and in other control design phases in different ones. You can edit an acknowledge function or a user parking function for managing directly the received bytes. Without the user parking function, the bytes are automatically converted in the declared input variables. Other elements of the window are the device, the local and remote IP address, the subnet mask, and the timeout for the network interface. In this case, the plant emulator with which we communicate is on the same PC. Then, the local communication passes through the loopback network interface LO, which by default has IP address 127.0.0.1 and net mask value 255.0.0.0. The plant emulator has been scheduled in order to provide one measure each millisecond, so the thread in which the processor activities work should work every millisecond. The timeout is here set equal to 1 millisecond. Once the project is configured, as this demo is, you can compile the project. In the report of the compiling process, you see that there are some warnings that you can view clicking on the warning button. But in this case, the warnings simply give the list of the blocks not active in the trial. For starting the trial, click on the Run RCP Manager button. The RCP Manager tool gets opened, apparently similar to the SIM tool, but it is a real-time program managing the multi-core and multi-thread scheduling configured by the user in SIM Builder and able to manage the interfaces with the plant. In this case, the real plant is emulated by the plant project to be executed in a separate instance of EICASLAB. So let's run another EICASLAB, always as super user, in order to exploit the real-time facilities. And in the second instance of EICASLAB, select the plant project. We have already described its system layout. Note that it is in RCP On Field submode for communicating with the RG control project. Let's compile it and then run its RCP Manager tool. So in the left part of the screen we have the RCP Manager tool of the plant project, while in the right part we have the RCP Manager tool of the RG control project. Let's start this project. The RG control is waiting for measure coming from the plant. Let's start the plant emulator. Now the two projects communicate and the trial runs. The graphical plot areas show a set of significant variables representing the trial going on. Now let's stop the trial. And in the next webinar we will going on showing the slow motion at work. Thank you for your attention.